Good afternoon. Am I audible to you guys?
Yes, ma'am.
Yes, ma'am.
Okay. So, anyone did homework? I asked you guys to find the grammar. Okay? So, just let me know your answers. So, this was the question. So, Kisnikel, anyone? Okay. So, what is the first production name? Where were you? S equal to A. Okay. Okay, let me do one thing because I guess it's a bit difficult to get everyone's answer. You can WhatsApp me your answers, but as a whole, I'm going to give you the answer. So you just check with this one, okay? Grammar, you already know. So here I've taken as A, B. So three variables. Terminal symbols and our starting symbol. So production rules are, you can use any symbol, just you can match with these productions, okay? S, A, solid, then capital E with two small b, or B, then A equal to lambda or your empty string, or small b. Okay, this is the production rule. Okay, moving on to this rule. S to A. This is one. So what are the possible strings here? First, let's check S equal to A and A. Okay. Then from here, I can replace A and B. Okay, from here I can go to B. Okay. Next, from B, I can go either to empty string or EB. So here I'm simply going to take lambda. Okay, lambda is empty string, so this is A. Okay, and this one is accepted because here written at least one. Some of you just wrote single A. You can check your answer and check whether something is missing or not. Or you can also WhatsApp me. Then I can check whether your one is correct or not. It's not necessary that you will just follow one type of production rule. It is possible that you can use different types of productions. Okay. Another is AA. Then now I want to replace with AA. So from here I want to go to A. So from here I will replace. Oh, nine. Oh, মই গৈছিলো. So from here A, I can replace AAB. Okay, from A to B. Then again from here, I can again replace AA lambda, and I can finally get double A, which is accepted. Next, try another one. Goes A to B. And now I want to replace A with B. Okay. From here, again, I want to replace with, from B, we can go to E and B. Let's take the other one, E and B. So from here, again, I can replace with lambda, then A. This is accepted. Okay, try other one. From here, you can go to A. From here, you can again replace with 3 A's. This is from here, you can replace A, capital B, then B. Then you can replace the ABs also accepted. Then try AB. From here, you can replace with B, AB. Just replace B. You can replace EA with the same one. It's A and BB. Lambda. It's A with lambda. Maybe A. B. So this is also correct. So what's the condition here? Number of M should be greater than 0. That means at least 1A. So all the strings we have generated, there is at least 1A. Right? Then N should be, number of B should be greater than equal to 0. So there might be a B in the string or there might not be any B. So this is also correct. So in this type of string, there is 1B, and in others, there can be B, 1B or more than 1 B's. Okay, and again, B is followed by the A. So all conditions are satisfied. This is the production. Okay, but yes, as I mentioned earlier, sometimes it is possible that you can generate different productions. Okay, so if you have big ones, you can check again whether all the conditions are satisfied or not. Okay. Okay. So this is all about the basics. We have already learned about लैम्डा नल मेंशन करना जरूरी हो गया क्योंकि प्रोडक्शन दिया हुआ है ना D goes to B. So from here you will go to lambda, then only lambda means nothing, then you will replace it with A. So it's a good practice that you just show. Okay, lambda null इसको replace कर दो. From B we went to this, right? So just write it down. Okay, so we learned about all types of grammar, 3 types of grammar. In next unit, I'll just start the base. First unit is all about like grammar, language, all the basic terminologies we learn like alphabets, strings, symbols. Okay, and what are the different types of grammar? What are the relationship among finite state automata and the grammars and the language? Like I mentioned, 4 types of grammar, 4 types of language, and therefore 4 types of automata. Okay, so we will learn it one by one. So first we are going to learn about the finite state automata. Okay, we will start from the finite state automata. So what is a finite state automata? I guess basic definition is already clear. Finite automata mainly what it does, recognize a particular pattern. And mainly we use automata just to know that whether a string belongs to a particular language or not, or whether string is accepted by the language or not. Okay, therefore means what? We basically recognize a pattern here. We see what is the pattern of a string, then we decide whether it is accepted or not. Okay, therefore it takes a symbol. Okay, it takes a symbol. So in finite state automata, since there are lots of symbols, it changes from one state to another state. Okay, there will be input symbols involved, and there will be some states. So you move from one to another state as per as your desired symbol, and there will be a transition. Just like here we went like AAB, right? So every symbol can represent a state. For example, A is a state. Okay, let's say 0 is a state, 1 is a state, 2 is a state. So from here it can go to A, then it can go to takes A and went to the second state, then it will go to third state. Okay, then it will take B. Okay, so all this time we just learn about the strings A. Now we will see how it exactly accepts the symbols. Okay, so there are 2 main things. One is transition state. Okay, there are some transition diagrams. Transition diagram is nothing but arcs and the nodes. Okay, transition state means like it accepts one string or one symbol, then it goes to one state. Okay, then we will learn about the transition diagram. Then there will be some transition tables. What is a transition table? Basically, the symbols will be given and the states will be given. And based on the transition table, you are going to design the finite automata. Okay, so there is a formal definition for automata. Like our grammar, it's a quadruple, right? So formal definition, you can represent with 5 tuples. Okay, 5 tuples, and those are Q, sigma, delta, Q naught, and F. Okay, this is the formal definition of your finite automata. FA. Remember this. Always remember. Formal definition. Now, what is a Q? Qunit means there will be a finite set of states. Okay. So, in a finite state automata, from the name itself, it will know there will be a finite number of states. It cannot move to like infinitely. There will be certain states and there will be definite numbers of steps or finite set of states. Then this sigma. Sigma means this is finite set of input symbols. Like A, B, C, whatever symbol is there. Okay. So sigma represents the symbols, whatever input symbols we have. Okay. The Q neighbor is the initial state. For the grammar, we have S, right? S means it's a starting symbol. So here Q naught represents the initial state. Okay. Then F means final state. So now you know in a finite automata, it's more like a diagram with arcs and nodes. You remember about your graph classes. Graph is nothing but nodes and arcs, right? Diagram is something like that with nodes and the arcs. So every node represents a state. So there will be an initial state given and a final state will be given. Just you have to find out the in-between things. Okay. Now there is a delta function. Delta function is known as transition function. Okay. It's a transition function. What transition function I will tell you more later. Just remember formal definition of finite automata is that it's a 5T. Okay. So this finite automata, you can actually represent it as an input tape. For example, think about if you remember your state data structure, or you can just think about the tape. You can also think about the arrays, right? Okay. So there is an input tape. This is your input tape. Okay. Then there will be a pointer or header. You can say this header is a control, or you can say finite control. Okay. So this input tape is like a linear tape and it will consist of some cells. Each of these uh, places are known as cells. These are your cells. Okay. And each cell will contain one symbol. One cell contains one symbol. Okay, for example, here you have A, B, C, A, B, B, and all. Okay, so in every cell there will be one symbol, and this is a finite one, and it is more like a controller, means it will decide from which position it will go to one. Okay, it will simply decide the next state or receiving input from the input state. For example, initially your control head is here. That means at this moment you are reading the symbol A. This is one state. Okay, for example, this is a one state. Just now. Then what it will do, it will go cell by cell and from left to right. It will move from left to right. So first it will read symbol A, then control will come here. Now the state is B. Okay. Then again it will move, it will come to the state C and will read the symbol C. Okay. So this is the main process how finite automata reads from the input tape and accordingly changes its states. Okay, there will be an input tape and there will be the finite control. So this finite control will decide what will be the next string in the tape, and accordingly the state will be decided, or it will move the state. Okay, so there are two types of automata. Two types. Okay, one is deterministic finite automata. Or you will know it as a DFA. Okay. Second one is the non-deterministic. Okay. NFA. So you always remember these two types of automata. Okay. One is DFA and the other one is NFA. Okay. DFA means from the name itself, it will know that what deterministic means what. Deterministic means the state will be definite. Okay. Machine goes from one state to another by reading just only one character. Okay. Machine goes to one state for one symbol. Okay. One symbol or one input symbol. Okay. Or one input character. Input symbol. Okay. And DFA does not accept null character. Null or null character. Okay, these two things you always remember. DFA, for one symbol, there is one state and it does not accept null. For NFA, using one symbol, it can move to many different states. Okay, it just transmit any number of states. Okay, for one symbol. Okay, for DFA, one state, one symbol. But in NFA, from one using just one symbol or one input, it can go to many states. Okay, and it does accepts null. That's the main difference between NFA and DFA. So constructing DFA is easier than NFA. NFA is a bit complicated. It's because it can go to any state. You cannot decide whether it will go from one to one. It can simply go to any state using just one. But for DFA, for one symbol, it can go to only one state. Okay, one symbol it can be 0, 1, A, B, doesn't matter. Whatever will be given in your question. But symbols can be 0, 1, any numbers or alphabets. Okay. Some points you need to remember is that every DFA, these are the common concepts they ask in questions, computer defense. Every DFA is NFA. Okay, but not the vice versa. But NFA is not DFA. Okay. And there can be multiple states, multiple final states. Okay. For automata, means DFA, there are two things in common. You will always get two things. One is two states. One is accepted state and one is rejected. Okay. To go there, you will finally get the final state. So all finite automata will have two states, accept state or reject state. So it can either accept a string or it can reject a string. Okay. So when your input string is processed successfully, then automata reaches the final state and it will accept. Okay. If string is rejected, it will not go to the final state. Okay. So there can be multiple final state for both NFA and DFA. Okay, for both. Your DFA is mainly used for designing your compiler. Okay, DFA is mainly used for your lexical analysis. Sometimes they ask DFA is used for what? DFA is mainly used for whatever compiler you have in your computer. Those are used for lexical analysis. Graph theory part you will get from lexical analysis in compiler. And NFA is more like theoretical concept. We mainly use DFA. Okay, I need to finish the class. I think it's a little bit okay. Okay, that's all for today. It's all theoretical. I'll try. I'm not sure whether I can do class tomorrow. Cross communication work will be there. If not, then we have to manage some other thing. Okay, Project Pandey, congrats for the topper in third sem. Good to know that. Okay, thank you all. I'm going to end the meeting, okay? If you have any doubts, you can ask. Today we just basically discuss about the theory part. Okay? Thank you.